Hello students, in today's class we'll be covering up the topic of set operations, and the content related to this chapter is basically unions and commutative law and associative law of union and of intersection, and certain examples that we'll also be covering up. So what are unions of a two set? They're basically set containing all elements that are in A or in B, possibly both. Here are shaded parts that represent A union B. Union of two sets, for example, A equals to a set with elements 1, 2, and 3, B with 2, 3, 4, and 5. So in order to list down the union of two sets, the union is represented with the letter U. And therefore, you basically combine all the elements from set A and set B together. So 1, 2, 3, 4, 5 is basically A union B. Or we can also write them down as X belongs to an A union B if and only if X belongs to A or X belongs to B. To know what a commutative law of union are, know that A union B is equal to B union A, and it is always true. In order to verify this, let's have a look at an example. Set A with elements 2, 4, 5, and 7, and with set B having elements 1, 3, 4, 6, and 7. So in order to verify this particular law of union, which is the commutative law, we first do A union B, which is basically combining the elements from set A and set B and putting them together, which results in 1, 2, 3, 4, 5, 6, 7. And in order to find out what B union A would amount to, it would be 1, 2, 3, 4, 5, 6, and 7. So hence, this verifies that the commutative law of union is true, that A union B is equal to B union A. To know what an associative law of union is, it is always true and should be denoted as A union B union C, which is equal to A union with the product of B union C. This property is known as associative law of union. So first, let's have a look at an example. First, you'll find out or sort the left-hand side, which is basically finding out A union B first. This amounts to 1, 2, 3, 5, and 7. Then you find out once you find out the A union B, you basically find out what the union would be with set C. Now A union B was 1, 2, 3, 5, and 7. Set C having elements 2, 4, 7, and 8. Once you combine these two particular sets, you basically result in 1, 2, 3, 4, 5, 7, and 8. And then you solve the right-hand side. And once you solve it, you first solve the brackets first. So B union C, which accounts to 1, 2, 3, 4, 7, and 8. Once you found out the union between B union C, you find out the union with set A, which results to the same as the left-hand side. So therefore, A union B union C is equal to the same as A union C. The intersection of two sets are denoted with this symbol N, and it consists of all elements that are both in A and B, meaning common elements, sharing of common elements between the two sets, and is usually the centermost intersectional space or the cross-sectional space shared between the two sets. Let's have a look at an example. Set A having elements 1, 2, and 3, set B having elements 2, 3, 4, and 5. To know what the common elements between the two sets would be, the red highlighted elements are known as the common or shade or intersecting points of the two sets. So therefore, the two elements become 2 and 3. So A intersection B is noted down with 2, 3. To know what a commutative law of intersection is, you should know that A intersection B is equal to B intersection A. In order to verify this, let's have a look at an example. 2, 4, 5, 7 for set A and 1, 3, 4, 6 and 7 for set B. First, we find out A intersection B. We result with elements 4 and 7. For B intersection A, we result with the same elements, 4 and 7. Therefore, it's verified that the commutative law of intersection is definitely true. To know what an associative law of intersection is, you simply replace the union with an intersection sign. That is all. So A intersection B intersection C is equal to the same as A intersection with B intersecting C. And in order to verify it, you have a particular example. Well, first you start solving off the left-hand side and the brackets first. So A intersection B first, and then you find the common intersecting elements with set C. Moving on to the right-hand side, we end up with the same result. Therefore, it is verified that yes, A intersection B intersection C, or the associative law of intersection, is true. Thank you so much. We hope that you understood the topic of commutative law and associative law of union regarding sets and set of operations.